Welcome, and great to see so many of you in this first session of our track. This track is KM Practices and Strategies, and as you know, there are practices all over the place, and very little, understanding of how we stitch them together into an overall strategy. So I think you're going to find this entire track, the whole day, very meaningful for you. And let me just ask, raise your hand if you're a KM practitioner, KM leader, CKO, manager. Okay, right. Keep your hand up if you're using knowledge graphs in your KM practice. Okay, a few. So you've come to the right place this morning because we've got just the right person to make our first presentation. And that's Dave McComb from Semantic Arts, who you've probably known and heard of. But knowledge graphs have been talked about within this KM world, the broader KM World Conference, down there at the end of the hall in text analytics. We've been talking about, and I've got some presentations over there too, for several years. And yeah, it's kind of frustrating to see why aren't these two worlds coming together. So I'm going to turn it over to Dave right now and let him start to stitch that together. You will not be disappointed. So Dave, take it away and show us how we can apply knowledge graphs to our KM practices.
Thank you, Art. The mic's on? Good. I like to wander around. When I put this together, I was thinking, this is going to be about how would we integrate the knowledge that we have in our knowledge management systems with our knowledge graphs. But then it occurred to me, sitting here for the last couple of days, many of you don't have knowledge graphs, or if you have them, you probably don't know where they are. They're somewhere else in your enterprise. So for the moment, think about what would it look like if your knowledge was integrated with your data? And then we're going to talk about how knowledge graphs are a way to get there. First, let me reveal my biases. I am incredibly deep in knowledge graph and very shallow in knowledge management. So you'll probably spot that here. I'm going to make some generalizations and some caricatures that maybe aren't true, but maybe how it is. Sometimes the caricatures, sometimes they're a little more true than we like to believe. Anyway, I work for a company called Semantic Arts. All we do is consulting. We don't sell products. We've been doing nothing but this, 100% of this, for 24 years. So we're just a one-trick pony. We do consulting on semantics and knowledge graphs. We've done it with a lot of companies that you'd probably recognize, some major projects with major companies. Also lots of projects with smaller companies, but there's no point in putting up logos you wouldn't recognize. And then, what was that? All right. So I am the CEO. I co-founded the company 24 years ago. Prior to that, I had a .com, of course, as you do. Did some very innovative stuff. Prior to that, I was flying around the world with what is now Accenture, building enterprise information systems. So I'm pretty deep into that side of the world. Not very deep, actually, in the knowledge management side. Somewhere along the line, about 20 years ago, it occurred to me that one of the problems with enterprise information systems was just how naive the designs are. The people that design them just listen to users, write down a few things, bunch of tables and columns, and before you know it, another silo is born. And I thought, if you really thought about what your information meant, you'd come up with a more coherent, simpler, and better model. So that was a book I wrote 20 years ago, didn't get much uptake. About 10 years ago, I wrote another book mostly to give to executives to light a fire under them, to say, you're just making this worse and worse. Every year, it gets worse. It's not getting better. We have more silos now than we've ever had. Everybody talks about that. And then another book, and both of these books are in the bookshop over there, about how to make it better. We call it the data-centric approach. It's, don't start with applications, start with your data, put your applications on them. Now, this next slide, the organizers here ask that we get our presentations in a month ahead of time. And I put this slide in, and I was going to say, does anybody know what this is? But then in the last day or two, all of a sudden, many of you are going to know what it is because it was in the news. In fact, I think it's literally the exact picture I'm going to show. I didn't plan that. And they presented here yesterday, and somehow I missed them. I went in the wrong room. I got sort of screwed up. So, doesn't anybody know what this is? This is the line. This is the city of the future. NEOM, they call it NEOM in Saudi Arabia. And the reason this is the genesis of this talk, we were involved in a consortium, and we were going to bid to do the smart city part of NEOM. Really cool project. We did not get it, but where this talk came from was in the process of doing that, they said, oh, we have a number of certified knowledge management tools that you have to be certified in one of them to be on this project. I'm thinking, I've been in this realm for 20 years. I'm going to know this stuff. And up comes 4 things that I've never heard of. I'm going, wait a minute. Knowledge graph, knowledge management, how do I not know this? And in fact, how do I wander around in the booths out here and have never heard of most of the products here? So it occurred to me, what's actually happening is there's 2 communities of practice that are literally like ships passing in the night. There's you folks and us folks. And I don't want to get into you and us, but it seems like we've heard of you guys, we wave in passing, oh, how are you? And you've maybe heard of the knowledge graph community, but I don't think anybody said, well, wait a minute, why don't we stitch these things together? I mean, it's sort of ridiculous to not to. It seems like a great opportunity. So that's where we're going. I'm going to put forward the idea that the knowledge graph community is really good at organizing and putting together flexible but powerful ways to organize data. Weirdly, and this didn't even occur to me until I started looking at it, there's almost no knowledge in most knowledge graphs. It seems odd, and in fact, in a minute, I'm going to get to where the term even came from and why that may be a little bit of a misnomer. Meanwhile, knowledge management folks have figured out how to elicit and write down and curate and get the really good stuff. I don't think you know where to put it. Yes, there's a lot of vendors out there, and yes, you could have a knowledge management system, but really, or SharePoint, it's really just the greatest hits of some content management system, which is weird, and fascinated with search. Search is it. I think we can do better. But in order to do that, I think we have to think a little harder about what knowledge actually is. I'm going to try and reframe that a bit here in this talk. And how would you link up your knowledge with your data? Okay. I did I'm going to do these very rapidly because I accidentally put too much stuff in the presentation. But here's the classic knowledge management definition. Other than being tautological, it also kind of begs the question, okay, so what is knowledge then? And then we get the Gartner group checking in again with blah, 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 blah. But here we have a different problem. It's all of an enterprise's information assets. Well, now you start going, well, what isn't knowledge? These 2 definitions are not helpful at all. Neither of them gets you even close. And then, just to get you up to date, because this one actually works for where I'm going later, this is a reasonable definition from IBM about what a knowledge graph is. And in particular, where I think it gives it away is right here. It's mostly about real-world entities. It's mostly about this clicker and this desk and that, your widgets in your factory and all that kind of stuff. It's not entirely about that, but it's mostly about that. And I think this captured it. And you start to see why there's a little bit of a disconnect. I came to this conference, and I think part of the union membership says you have to put this pyramid in. But since I've always found it a bit dubious, I went with Stan's version that's a pyramid scheme. And his point was that this pyramid tends to say, oh, I'm just filtering and condensing down. And it's not filtering. These are kind of different things. And by the way, the definitions aren't very good at the top. But what's interesting, from my standpoint, is this is where we live. This is where I spend my days, trying to reorganize this mess that is in your enterprise. And this is where you guys live, mostly. But why aren't they connected is the question. So I'm going to spend a little bit to bring everybody up to speed. I can't do a full treatment of what a knowledge graph is, but I want to get a few of the essences of what a knowledge graph is. But before you even know that, you have to know, even if you don't know what it is, you should know that it's being hyped right now. And anything that's being hyped, you know, this is the Gartner hype cycle. So here, this is not the hype cycle of knowledge graphs. This is the hype cycle of artificial intelligence. 2 years ago, knowledge graphs were at the peak of inflated expectation. Oh, that's a horrible place to be, except it's the next to the horrible place to be. The horrible place to be next year is in the trough of disillusionment. You know, it's where everybody's disappointed. But this year, look at that. We're already in the slope of enlightenment. By next year, we'll be in the plateau of whatever it is, productivity. Okay, so that doesn't tell you what it is. That just tells you it's being hyped. What is kind of interesting, knowledge graphs are based on graph databases. Graph databases have been around pretty much forever. Back in the 60s, there were graph databases. They didn't really catch on. Relational caught on. They were kind of a side project. Right around the turn of the century, the W3C, the people that brought us the World Wide Web and all that other stuff, also created a standard called RDF, Resource Description Framework, but it's a standard of how to build a graph. If you want to build a standards-based graph, do it this way. Vendors showed up, a few at first, but somewhere around 2006-ish, they started, to really get some traction, get some sales, get some projects. Does that sound about right, Jans? Yep. So there's an industry starting to develop. They call them triple stores because these graphs are in little triplets. We'll see that in a second. And in parallel, Ward Cunningham's inventing the wiki web, and Jimmy Wales is turning it into Wikipedia. So we got Wikipedia around 2000. And then Soren Arn and the University of Berlin looks at Wikipedia and says, those little info boxes over there on the side have some easy to scrape information. I'll just rip those all off, those little info boxes, and put them in a commercial triple store, and created this thing they called linked open data. And it's open, it's public, it's standard, it adheres to those standards. What's amazing is there are hundreds of billions, there's probably trillions of triples out there just to be downloaded and included with things There's public knowledge that is being widely ignored. That's just that's happening around 2008 or so. One company sets up shop outside there, sucks down a few 100 million triples, combines it with some of their own proprietary stuff, starts selling whatever it is they were selling, better search, I think. And Google comes along in 2012 and acquires this company and acquires their product called Freebase. It's kind of an edgy name. Then it goes dark in Google, as things do, for about 2 years, and emerges as Google's knowledge graph. I think this is where the knowledge graph label came from, because I think throughout all the rest of this, it was just graph databases and triple stores and RDF and whatever it is we're doing. And this is, in some ways, why there's not a lot of knowledge in a lot of these. So, how do we put data in a graph instead of in a relational table? What does it look like? How is it structured? How is it organized? Why is that different and better? Here's one of my favorite little pieces of data. In fact, for a while there, I thought this was AI generated, but first I did some research in Wiki, and then I found out of the 3 gold hills, there's only one that was actually founded in 1859, and it's in Colorado, and it was only an hour and a half from where I live, so I drove up there. It took me quite a while to find this damn sign because they moved it. It's not near that house that you see in that picture, but it's exactly, in fact, I have a tea towel with this information on it. Anyway, and by the way, this is high quality data. I've done the math. It adds up, right? So let's take a little tiny chunk of data. I think everybody in that DIKW pyramid would agree that 1859 is at least a piece of data. That's data. Out of context. In graph databases, we establish the context by drawing circles and arrows, basically. That's the high-tech idea there. But really, the hidden, interesting gem is this semicolon. And you know, because of PowerPoint, I don't want to put the whole what the semicolon is really hiding. But what it's hiding is something that makes that globally unique. And it's actually globally uniqueness is the kind of the secret sauce to what we're doing here, as you'll see in just a second. But just know that behind any of the colons, including the one called established, there's what they call a namespace, very much like the XML namespace. But what's interesting, 99.9% of everybody who does this mints their names in a domain name that they own or control, which is how you can have global uniqueness without all that gobbledygook of GUIDs and GUIDs and UUIDs and all that kind of stuff, which are globally unique but not useful. These are globally unique and useful. So if you have a namespace like that, I just made that one up, you can append what they call a fragment at the end. That is a globally unique identifier. That means this place called Gold Hill, no matter who, and if GeoNames chose to what they call resolve this, you would just put that in as a URL, and they would tell you whatever they want to tell you about what they know about Gold Hill. Maybe they're selling information, they only tell you part of it, but it's potentially resolvable. Which leads to what the W3C calls this idea, we want to build the system around things, not strings. A relational database is just a whole bunch of strings. It's just literals. And you, some human, have to figure out the string that represents the column heading plus the string that represents the ID has to get attached to the string that represents another column heading in another table. You know, And actually, most of your knowledge is just strings. That's why you search it. But we want to get to things. Gold Hill is actually in the real world thing. So we say information about things with this device called a triple. Triple is just two nodes with an edge. And the nodes can either both be things, or the previous one was a thing with a string. There are a few strings. They're kind of leaves on the edge of a graph. So that's the basic building block of graph databases. These are little tiny sentences. They say it's a subject, predicate, kind of an object. You can usually read these things. They read nicely. Gold Hill is located in Boulder County. You might have thought that was Boulder, Colorado, but now, what's interesting, how this whole linked open data thing I was talking about works, is if I discover some data somewhere else, maybe Gold Hill doesn't know or forgot or assumed everyone knows that Boulder County is in Colorado. But if we find that somewhere else, like maybe in Wikipedia, that's another triple. But those are globally unique identifiers. You don't need any metadata to do what I'm about to do, which is snap them together. Because they have the exact same globally unique identifier, they are attached. That is what a graph is. That's how graphs self-assemble, and that's how you can self-assemble a lot of the data in your enterprise. Now, here's one of the commercials for the early days when Google had adopted graph technology and had their knowledge graph. You know, you can see Da Vinci painted the Mona Lisa, and Lily is a person, and you know, they're kind of explaining how it works. But look at that. There's pretty much nothing that I would call knowledge. These are facts and assertions and data and opinions. They don't quite rise to the level, I don't think, of what you guys deal with. This would not help you in your customer service thing that we're going to see in a minute. What I found kind of interesting, especially this week, seems like I went out and I boned up here. I read e-gains and knowledge management for dummies. All the case studies are customer management. I went out on Enterprise Knowledge's website. We got customer management. The keynote, it was customer management. I get it that that's a tractable problem. I'm not sure that's really the highest and best use of knowledge management, but we're going to go with that because I have an example that works here. You know, knowledge management in the world of customer service is putting together FAQs that either the self-service person can use or the attendant. Let's look at how this actually works. We did a project. There's a very interesting company that's now called TalkMap, who was into LLMs 4 or 5 years ago. I mean, they're way ahead of this. And they were scraping customer service conversations, millions of them, and establishing the patterns of how people took turns and how did they resolve problems and all that. And we built the ontology and the knowledge graph for that, but they did all the heavy lifting. So what typically happens, user phones up, somebody talks, back and forth, 2 or 3 turns just to figure out that you have, this is the turns down here, that you have an account, and then back and forth for a while to figure out what the problem is. And there's these little nuggets of knowledge, I'm going to suggest, that somewhere somebody, after doing this hundreds and thousands of times, discovered, you know, this is going to be an invention of a summary of something we did with PayPal, so I know them a little bit better. If you made your original purchase with a credit card, it goes back to that credit card, even if you've canceled it, just kind of too bad, and it usually takes a couple of billing cycles. This, I would suggest, maybe rises to the level of knowledge. You might argue that. But let's look at what that would look like in the context of a knowledge graph. The phone rings, the system looks at the caller ID, figures out that you do have an account with PayPal, and furthermore, because it's just another triple, notices, oh, you just had a transaction recently. And that transaction happens to be a refund because it's categorized by one. We're going to get into how taxonomies fit in with ontologies here in a minute, but right now it notices that. It thinks maybe that's what you're calling about. And it's armed with this little piece of knowledge that is attached to the idea of a refund, and it says refunds go back the way the original purchase was made. But at this point, the caller has forgotten. You know, by the way, the caller's been in an argument with the vendor for about a month. They go back and forth, and PayPal has all these escalations and lawsuits and all the, and they argue like crazy, but eventually the vendor caves in, oh, I'll give you a refund. 20% of all calls to PayPal are, what's the status of my refund? Because immediately the vendor says they gave you a refund, you go in your PayPal account, it's not there. And of course you forgot how you paid for it. And if it's the bank account attached to your PayPal account, your credit card, there's all kinds of ways in each one of them. But this little factoid says that's where you should look. But the caller has forgotten and the vendor's not even in the conversation. But actually PayPal knows, they just had it in another system somewhere. Bring that back, connect it up, you say, oh yeah, that purchase, you used this payment 453, which by the way was a credit card. Our second little piece of knowledge attaches in here and we say, well, if you refund by the credit card, and a little dotted line, what we inferred, you should see it on one of those two statements. So that's what integrating knowledge with a knowledge graph can look like. Now we have a problem. We have a new problem. So I've got these little nuggets of knowledge. Where am I going to put them? And actually, by the way, I don't see him here. Did anybody see Mike Gilger's presentation yesterday? It was very excellent. If you get a chance, you know, when you go back and you see the recordings, it's the second half of A201 or one of those, where he had a beautiful demo of taking the knowledge and putting it into some content objects in the graph, which I think is huge. But we're going to go one step further. Where does it really belong? So Knowledge graphs have these things behind them that's called ontologies. It's essentially the data model. It's a much more flexible data model than a traditional relational data model, but it's how we know what things are. And people often start with what they call an upper ontology, a high-level concept. We have one that we've used on about 98 of our 100 projects, so it's gotten a lot of exercise. We call it GIST. It's free. It's on our website. If you're interested, just download it. You can freely use it. I had an artist work on a way of rendering it. It just actually has 100 classes, but really there's about these 14 that almost everything in your enterprise falls into one of these buckets. It's kind of wild that this could possibly be true, because if you're in a large enterprise, you have thousands of systems. They each have thousands of tables and columns, millions of things. You think they're all an incredible variety, but no. You got a whole bunch of physical substances. You got some gold and coal and medicine and water and stuff. Physically identifiable items includes people, but also your equipment, your cars, and vehicles, and your buildings. Geospatial regions, organizations, etc. There is a place for content, and we might put knowledge in there. But hold that thought for a minute, because there's several other. I'm not going to go through all of them right now, but they're kind of self-evident. When you build an enterprise ontology, you extend this, usually to the tune of hundreds of classes, but not thousands. And if we can organize our enterprise's data along this model, all we have to do is attach the knowledge to it, and we can bring the knowledge in context of the data. Ontologies don't actually look like this. They look a little geekier. This is from one of the tools that people typically use, but just to give you an idea, we're going to make it look nice. Kind of an idea what it looks like built out. Now, maybe knowledge is intellectual property in the abstract sense, not as a document. A patent is intellectual property not because of the patent application piece of paper. It's because of the protection you have for your invention. And I'm also going to talk a little bit about categories. We use categories a lot. 2 or 3 brief slides on categories. This is where we put taxonomies. There's some people here from the taxonomy boot camp. Every once in a while we hear some people say ontologies are too hard, let's start with taxonomies, and then we'll turn our taxonomies into an ontology. I've heard that a lot. That is a horrible idea. Almost all the bad ontologies we see are that. Better you do it the other way around. Build an ontology and figure out what things am I trying to categorize, and therefore what taxonomies do I need. And they end up being smaller, simpler, and more faceted, which makes them more usable. So, and just to get an idea of how the power of separating ontology, taxonomy, and data is, and how it's actually about leveraging the cognitive load of the human mind. There's in semantics they call it the terminological box, or the T box, is where we make up new concepts, new terms. And typically you should have hundreds of those in your enterprise. It's surprising how few you need. Then you'll need, this is a term we made up, thousands to hundreds of thousands of specific taxonomic distinctions. There'll be groups of people that govern these and figure out what they all mean. And then, depending on the size of your enterprise, you may well have billions of individual facts that are organized around these things. So, earlier I said knowledge might be something more than just content. A lot of knowledge is categorical knowledge. We are category making and category using animals. I think even more so than tools. We make up categories, which are just invented things, and then we attach knowledge to them. Carrot, in this case, is not that orange thing in the supermarket. It's what we know about carrots. Carrots are a type of vegetable, and we know things about how long they take to germinate. But not everything that knowledge is attached to is a category. There are places like Fort Collins. We can have knowledge about a place. We can have, in the legal system, we have knowledge about judges. We know that Judge Jones is more lenient on repeat offenders before noon. I mean, that's knowledge, and it's attached to a person. So knowledge could be attached to many different things in the ontology, but there's a few bits of almost pure knowledge. One other thing before I get to the pure knowledge. So in a knowledge graph, we assert facts with these edges. We say this event occurred at that place. That's just an assertion. It's just a fact. You can verify it or whatever you want. Most knowledge, and I got this from one of our clients, is usually fuzzier. There's a predicate that has some fuzzy meaning. It usually, and even when they say causes, they mean usually causes. It's not that it caused in the past tense. You can take a picture of this because I'm not going to go through it, but here's the main extensions you would probably make in each domain to capture these pure knowledge objects. The gene in medicine is something we discovered, but it's not my gene, it's what we know about FOX2, and we keep accreting things to it. But keep in mind, it's kind of an imaginary thing in a way. And then, each domain has a handful of things. You can have knowledge about anything, but these are the important abstractions that people have typically picked up. So I'm going to suggest, and in fact, I heard this from a couple of the talks about knowledge not being the filtering of data and information, but the distillation of experience. If you've done something hundreds of times, you learn something that you generalize out of your experience, not out of the data. So, and that's why they're disconnected. Data and information are usually about these real-world instances. We've got some data about something, whereas knowledge is usually about what we learned. It sounds sort of self-evident, but I had a tough time finding it actually expressed that way anywhere. But that means it would be pretty cool to connect our data with our knowledge. One more extra bonus thing here. We talked about triples to have 3 parts. They really have 4 parts. It's kind of a misnomer. Let's say this is real-world data. This particular patient had an A1C reading of 8. That's just something you went out and did. Could happen. That statement, that triple, actually has a 4th part. It's called a named graph. You can put a literal in there if you want, but it's actually much more powerful if you put another thing with a colon in front of it, a URI, and say, how do I know that? That, I could have more triples and say, where did that piece of data come from? It came from that particular lab, that particular panel, on that particular date. The provenance of every piece of information in our knowledge graph is right there, one click away. And if that's true, can we have provenance for knowledge? So this might be a little nugget of knowledge that diabetes, the disease, is ruled in if your H1C is more than 7. Sounds pretty safe, but you might wonder, well, wait a minute, where did that come from? It says who, and is that contradicted yet? That is just another triple, just another fact or another assertion in the triple store. It has provenance, and you could click on that and say, yeah, where did that come from? You point, right back to the journal, or could be anything. Did you miss the picture there? You got it? In different domains, in law, it's called shepherdizing to figure out which case is precedence for which other case. In medicine, they have something called Cochrane, where their evidence and clinical trials are just that. It's getting a whole lot of data and coming down to a little bit of knowledge, and then you want to remember where that knowledge came from. So, I made it. Remember these 2 ships passing in the night? The whole thing I want to talk about here is that I think these 2 ships should dock. We should actually get together, right? You guys should come to our conferences. We should come to more of your conferences. We should talk. So now I'm going to close with it's an alliteration, but I forgot to put the right words on the title, but it's a recap, a request, and some resources. those right titles. Remember where I started here? I said, and I think it's true, the knowledge graph community has figured out pretty good ways to organize and bring data from many places to one and integrate it. You guys have figured out how to capture knowledge because it's coming from experience. It's not, like Stan said, it's not coming from the data. Now, some experience gets put into data and we might mine that and find some stuff, but a lot of it is, like real experience. And I'm going to suggest that most really useful knowledge is the distillation of experience. So as we saw there, if you use a knowledge graph, you can tie knowledge to its source, that's provenance, and you can connect and you can bring it to bear at the point of use. That little example with the call center and the system, oh, you had this transaction, it's this, here's my knowledge. Maybe I give that little piece of knowledge to the attendant, but maybe you just tell them on the phone, by the way, go look in your Visa account number 742, it should be their next cycle. I mean, that's 20% of all the calls to PayPal, just there. And all you have to do is put your knowledge in a knowledge graph. So now what? I'll tell you what we're doing. In fact, I periodically stumble over knowledge in our projects. We mostly deal with data and information, but every once in a while somebody comes up with something, ooh, where would that go? And we usually stuff it someplace inappropriate. It's only been in the last few months we've been dealing with our team. But we're gonna, that little K for knowledge is not the final class name, but there will be one very much like that and probably in the intellectual property area. So we're gonna have a place to put it. There's a lot of public domain ontologies that have expressed knowledge, but not expressed it very well, especially in the medical domain. So if you're in the medical domain, you know what I'm talking about. And we're looking for clients that want to give this a whirl. I think it's seems pretty promising. Here's my request. I originally pitched this as a keynote, and the organizers here don't know who I am. If you think that this is something maybe a broader audience should hear, put something in your review thing. If you think this guy should never come near this group again, you can put that too, or you can put both. I don't know. Now, and here's some resources. If this is of interest to you, here's a couple of places to get started. We have a couple of communities of practice, if you will, that are open to the public. If you go onto our website, it's not very, we're reorganizing our website, but I think that will still fit. There's one of them's called the Estes Park Group, where we look at what architecture do you need if you're going to implement this, and a lot of vendors and stuff come to that. The other one's called the GIST Forum, where people just talk about what's the best abstraction to represent these things. So if you want to do that, we set up this thing we call the Data-Centric Manifesto, and it's a great bit of inspiration to me. Every once in a while, there's about 2,000 people have signed it, and they go in and just say, yes, we totally believe in this. There's a lot of frustrated people out there because they know what's right and they're struggling to get it done in their organization. But sometimes it makes you feel good to know other people are too, and we will eventually prevail. And if you want to, just contact me. And that is it. Thank you.
So would you like to hear more some other time? Raise your hand if you want to hear more of this. If this was good. All right, we've got a couple of minutes for a quick Q&A.
Yeah, I didn't think I was going to make it. But,
so if anybody has a question, quick question, raise your hand. Okay, there's a lot here. I don't know about you, but my mental knowledge graph is full
There's
right
one.
now.
There's a question.
Okay.
Not sure if I need a mic, but
Yeah, it always helps.
there's this example about the PayPal, and you were linking kind of credit card transactions into the knowledge graph. How do you deal with the high volume of transactional databases in commercial transactions against a knowledge graph? How do you tie them together, and are there any issues with the data volumes and database performance?
Yep. The question, and I guess everybody heard it, is on the mic. Generally, we don't sweat very much until we get into the billions of triples. And even though there's millions of conversations and therefore billions of triples, you just shard it essentially like you would with any other relational database or any other kind of data store. But we're also, one of the things that's great is because this is an open standard, the vendors are constantly competing against each other on performance. And some of the things I've seen are quite incredible. We may even have Jans say something here, but we've seen, well, the UniProt, which is everything that everybody knows about proteins, is 150 billion triples in an RDF triple store. We've seen other things with trillions of triples. So it takes a little bit of tuning as you get up into the billions, but and a little bit of, let's only have this month's transactions here because that's what people are calling about, but let's have history over there and just not slow us down. But it's starting to scale pretty well.
I think about, you want more questions? Sure, go ahead.
Could you talk a little bit more about why it would be better to do an ontology before a taxonomy?
Yeah, in fact, the one slide I'd like you guys to take out of your taxonomy decks is the one where you compare it to either Carl Linnaeus or Melvin Dewey. And it's because there seems to be this desire to have one giant tree that organizes everything. And then if you do that, if you create this as a taxonomy, and then you copy it over and say, oh, those are all classes, you now have this gigantic ontology. In fact, if you look at most of the medical ontologies, that's exactly what they are. Tens of thousands, hundreds of thousands of classes, most of which can't have any instances, which is kind of hilarious. And instead, if you said the ontology is about what it is I want to categorize, it's about people that have diseases and procedures and things like that. So if you get that ontology right, and then you say, oh, how would I like to categorize people? How would I like to categorize disease? And it ends up with a much more fractal, a lot of small taxonomies instead of one gigantic one, which seems to be way more useful. I don't know if that made sense.
Okay. Another round of applause for our speaker, Dave.